What's going on, guys? Today I'm going to be showing you guys how to make a jam jar pulse jet out of these simple supplies. The first thing you're going to need is some sort of jar. For us, a small mason jar or a jam jar, hence the name, jam jar pulse jet, will work just fine. The next thing you'll need is a lighter or matches, and then a bottle of heat, which is just methanol basically, and that's why it combusts. So the first thing you'll need to do is put a hole on the top of your jar lid. For us, about the size of your pinky finger or like a small 9mm bullet casing should work. This next part is completely experimental. The amount of heat required and the size hole on the top of your lid is completely dependent on the size of your jar. For us, a very small amount of heat is required. The next thing you're going to want to do is move anything that's flammable far away from the jam jar pulse jet. And while lighting it, make sure to keep your face clear of the top hole because it does create a lot of upwards thrust. That was a working jam jar pulse jet, bro. To turn off a pulse jet, simply step on the hole. You're going to want to make sure to not let this pulse jet run for too long because the glass will crack and the methanol will go everywhere and you'll create a huge mess of fire and methanol. You're going to want to let it sit after you've had it on since it is incredibly hot. Before we go, I'll show you guys what a jam jar pulse jet looks like in the dark so you can see all of the individual cycles of how pulse jet actually works. There are three main phases while a pulse jet is turned on. There's the intake phase, the combustion phase, and the thrust/exhaust phase. There's also the initial combustion phase, which is slightly different from the others, since in order to actually get a pulse jet to start working, you're going to have to shake it up and make sure the molecules of methanol are mixed with air molecules so that the mixture can actually combust and get the pulse jet to go. The combustion phase occurs once the air-to-fuel mixture ignites and causes the thrust phase to occur when all of the mixture pushes through the top and creates thrust downwards. The intake phase happens after the thrust phase. The thrust phase pushes a bunch of molecules out this end, which creates a low pressure area inside of the pulse jet, which causes air to rush back in, mix with the hot exhaust fumes, and then ignite yet again. And the cycle repeats over and over and over, millions of times, not millions, thousands of times a second, which creates that signature pulse jet sound. So the cycle essentially goes initial combustion, thrust, intake, combustion, thrust, intake, combustion, thrust, intake, combustion, thrust, and then that's just how it continues going until the glass either gets so hot that it cracks or you have exhausted your entire fuel.